45-year-old cerebral palsy victim who was also inflicted with scoliosis of the back and a flat foot deformity. Susan has a problem as a result of her disability. She has difficulty dressing and undressing herself in the bathroom after toileting. The members of my group, being Greg Linscott, Kurt Humphrey, and myself, Scott West, dedicated our talents to designing, building, testing, and installing a device to assist Susan in this dressing procedure. In the following footage, shot on location at Susan's home, you will meet Susan and get an idea of the limitations imposed by her disability.
I go like so with my chair into the bathroom, and I go across the bathroom floor, and I turn my chair like so. And I place my backside to the wall.
As you can see, Susan has very little strength, mobility, endurance, or pincher controls. She also goes through a very lengthy, dangerous, and exhausting dressing, undressing, and wiping procedure. Graphically depicted here is a plan view layout of Susan's bathroom. To begin her toileting procedure, Susan enters the bathroom through the doorway and grasps her chair, which generally rests against the bathtub and underneath the towel rack. Susan then makes her way across the floor and against the back wall, where she lowers her pants. From here, Susan grasps her pants in her one hand while holding onto the chair with the other and scoots across the floor, sits down at the toilet, and completes her toileting duties. She then stands up, still grasping her pants in one hand and the chair in the other, scoots back across the floor to the towel rack area, where she bends over her chair and completes her wiping stage. Susan then returns to the back wall, pulls up her pants, and moves over to the sink area, where she will dispense of the toilet paper in the toilet, wash her hands, and exit the bathroom through the doorway. As you can see, this toileting procedure has many downfalls. What was needed was some sort of a device to greatly increase the safety of this toileting procedure. This was the #1 design requirement. Other factors also considered were stability. The device must be able to support her before and after toileting. The device must be somewhat portable, inasmuch as if Susan was to ever move, the device must be able to go with her. It must be very simple to operate and require minimal manual dexterity. It must also take up a very minimal amount of the very valuable bathroom space that Susan has right now. It must have some sort of a back support. Susan preferred to have some sort of a wall that she could lean against when raising or lowering her pants. And it would be very convenient if all facets of toileting were contained in a small adjacent area to the toilet. Of the overhead safety bar design is comprised of 3/4 inch plywood, double wall thickness. The rear wall of 3/4 inch plywood is directly bolted, or screwed, I should say, to the studs in this wall right here. There are 3 studs, and there are 4 screws in each stud. Attached directly to the backing plate is a 2x2 pine frame. The frame runs along the design, down this side, and frames in the walls. There is a 3/4 inch faceplate attached directly to the frame with 1.5 inch drywall screws placed at 6 inches on center at the top and 1 foot on center at the bottom. wall shape is coped out to allow for an existing 1¼ inch diameter grab bar, and also coped out to allow for existing electric thermostat. The backing wall is 57 inches tall. The backing wall is also 57 inches long. The extended wall is attached directly to the frame of the lower part of the backing wall. The purpose of the extended wall is to assist Susan when in her wiping stage and to give her additional safety by providing a large, sturdy object to hold onto. The extended wall is exactly 31 inches high. As you can see, this was not done by mistake. It's exactly the same height, or plus or minus ½ an inch, as the chair she had once used to lean over and wipe herself. Rolling. The extended wall is also 20 inches wide. As you can see, jutting up from the extended wall is a 1-inch diameter conduit which serves as a grab bar for Susan. The grab bar is positioned so that when she's leaning over the extended wall in her wiping fashion, she can hold on to the grab bar. The grab bar is 1-inch diameter steel conduit and has 8 5/8 diameter bends coming up from the wall, extending out, returning back into the wall for a nice, sturdy design. The height of the grab bar is 41 inches off the ground.
Red safety bar, it's a aluminum pipe. It's 1¼ inch Schedule 40, and it's made out of 6061 T6. It's good for 41,000 PSI, as you caught me sitting on it, because it's a pretty comfy bar. A little dirty, but it's made up of 6 7/3/8 inch bends all the way around here, and it has 4 weld spots in it. The welds are V-groove to get better penetration in them, and they also have machined aluminum plugs. Pins, whoops, the pins, sorry. Ben Dresser, over the ag engineer, he corrected us on this terminology. We like to call it plugs, but he refers to them as pins. The bar is mounted to the backing wall by 1/8 inch steel, and we got one plate molded over the aluminum, and we got another plate in back of it, and another plate in back of the wall, all act as backing plates. Now, for this hinge, we got a cover plate here, 1/8 inch steel, and we have molded around the aluminum bar here. We got another 1/8 inch steel bar in back of here to protect the backing board, so the aluminum doesn't wear on it. We also have another one of these 1/8 inch steel backing plates in back of this 3/4 inch plywood. That's to hold it all together. We have a piece of 3/4 inch plywood here to act as a backing so it won't block the stopper, so it won't push out. And the bar is covered with white lithium grease to add as protection so it won't rust and for lubrication. The plates are held together by 3/8 inch bolts. As in its already up position, we have just a ½ an inch clearance, just enough for me to get my finger in there before it hits the stopper, which acts as a cushion so the bar won't go through into the next guy's bathroom, which would be uncool. And these beauties right here are nothing more than a $3 sanding block, but they act as great as a cushion so that it doesn't go up against here and maybe possibly go right through. This right here, this 3/4 inch plywood, acts to bring it out so it lifts the bar up so the chair will slide in nicely.
They match paint.
And plus, as an added feature, they also match our paint.
Alright, I'm here to talk about the counterbalance mechanism. The reason for the counterbalance mechanism is twofold. First reason is to hold the bar in the upright position. If it wasn't for the counterbalance system, there'd be nothing holding the bar against the wall. The second reason is so Susan can easily pull the bar down. As you will take note, the bar will stay right in this position due to the counterbalance. And this only requires probably 3 pounds of force. That's why I'm doing the counterbalance mechanism, not Kurt Humphrey. Next you'll notice this is 3/16 nylon braided rope. It has a working strength of 120 pounds force. The counterbalance is only 12 pounds, so that leaves us with a safety factor of 10, which I say is pretty good. The rope is attached by threading through an eye hook around the bar and tied back to the eye hook. This eye hook supports the counterbalance in no fashion. The pipe does all the support. The wood screw is just simply for alignment purposes, so the rope will not slide. If this wood screw was to come out in the upward position, the bar would support the rope. As you can see, up top, we have one swivel pulley and one fixed pulley. As you can see, when I take the bar up, the pulley will swivel slightly. The swivel is very minute, but we need it for alignment purposes. As you can see here, this is a 12-pound counterweight. This wrapped with padded foam to prevent wall injuries. Up here supporting this mechanism is a 2x4. There are no studs in the ceiling due to government housing, so we had to get sheetrock screws. They're expandable on the other side of the ceiling, and this will support the counterweight with no problem at all. This here, what you're looking at, is an emergency safety switch. If Susan would get in any trouble whatsoever, all she'd have to do is pull on this, and it would signal a buzzer and a flashing light outside her apartment. And all we did here was to put a little wood screw to reroute it at enough angle so it wouldn't bind in our hinges. Next thing I'd like to talk about is this $8 leather dog leash. This just allows Susan to pull down the pipe in her wrist much more easily. And she has problems grabbing the bar.
Enough technical data, and now the grand finale.